Here we go, 10:26 on a lovely Tuesday night. We are now going to talk a little bit about what happens when there's a vertical shift in our sine and cosine graphs. They're going to move up and down based on a certain number in the function. Here's another picture of the basic sine graph, again going 0, 1, 0, negative 1, 0. One thing we really haven't talked about a lot is how there's this term called the baseline. The baseline is the middle, the vertical middle of the function, and when it's the basic function, the baseline is the x-axis, or the line y equals 0. If you don't remember why sine goes 0, 1, 0, negative 1, 0, check your 90s on your unit circle. Then here's the basic cosine graph. Cosine goes 1, 0, negative 1, 0, 1, still has that baseline on the x-axis, or the line y equals 0, because we have not shifted the function up and down at all. The reason both of these functions have a baseline on the x-axis is the fact that, so both of them have a baseline on the x-axis, is the fact that there is no number being added at the end of the function. If there were a number out there, right now, again, the number is 0, and so we've got plus 0, plus 0. That's the reason our baseline is on the line y equals 0. But if we do have something added or subtracted at the end, the entire function will move up, or if it's subtracted, the function will move down. For example, we have a sine graph here, or sine function, where we have y equals sine of x, and then notice that the parentheses are closed. If the parentheses hadn't been closed, we'd have a different story here, but the parentheses are closed, and then we add 3. This plus 3 at the end is going to take and move the entire function up 3 spaces. And so we'll look at that visually in a second, but first let's go ahead and do it on our chart. Because if we're going to move a function up 3, that's going to change not anything about our x-coordinates. Moving something up doesn't change anything about x-coordinates, because x-coordinates measure left and right movement. And so we're going to add 3 to all of our y-coordinates. So the 0 has now moved up to 3. The 1 has moved up to 4. The 0, again, is at 3. The negative 1 is not at, well, is negative 1 plus 3, which is actually 2. It's not 4 there. And then we add 3, and we get 3. So this is our pattern this time. Instead of going 0, 1, 0, negative 1, 0, we're actually going 3, 4, 3, 2, 3. And so we'll go at 0. I need to keep that here. At 0, our function is at 0 still. So that's, I'm sorry, this time at 0, our function is at 3. And at pi over 2, our function is up at 4. At pi, our function's back to 3. At 3 pi over 2, our function is at 2. And then at 2 pi, our function is back to 3. And so this is, as you can tell, taking the entire function and moved it up 3. Again, I could keep going with the pattern. It would go back to 4, 3, 2, and back to 3. So here's what the function would look like all the way. But we're mainly focused on this first cycle here, and you can see the entire function just moved up 3. As we did that, it also moved our baseline up 3. So our baseline is no longer on the x-axis at y equals 0. The baseline is going across here at the line y equals 3. So the baseline moved up as well to y equals 3. The same thing will happen when we're dealing with cosine. This time the cosine actually had a vertical shift of negative 2. So this is going to take our entire cosine function and move everything down 2. Moving something down 2, again, will do nothing to our x-coordinates, so our x-coordinates stay the same. But our y-coordinates will all move down 2, and when we're going down, we're going to subtract. And so we'll take away 2 from 1, we get negative 1. Take away 2 from 0, we get negative 2. This will be negative 3. This would be negative 2, and this would be negative 1. So I'm actually going to grab that and bring it a little closer so that hopefully I can see that as I graph. And I can, good. So at 0, we're at negative 1. At pi over 2, we're at negative 2. At pi, we're at negative 3. 3 pi over 2, we're back to negative 2, and 2 pi, we're back to negative 1. So I'm going to draw my cosine graph again as smoothly as I can here, and recognize that we can tell everything has been moved down 2, including the baseline. The baseline is no longer up at the y or the x-axis. The baseline is now down here at negative 2. And again, the function would continue all the way forever and ever. Now we're going to try to put steps 1 and 2 together. This function's got a change in amplitude as well as a change in vertical shift. It's been moved down 3. When you have a change in both amplitude and vertical shift, you've got to take care of the amplitude first. So here's our sine chart. We're going to go ahead and double all of our y coordinates first. So we'll take and double all of our y coordinates. So this becomes, again, our x coordinates won't be touched here, but our y coordinates will all double. Well, doubling 0 doesn't get you anywhere, but doubling 1 gets you to 2, 0, negative 2, and 0. Now, one more time, our x coordinates will not be touched, but now all of our y coordinates are going to move down 3. Now it's important you move the new y coordinates down 3. You take these y coordinates and move down 3. That's why I have the step-by-step charts here. So 0, take away 3, will leave me at negative 3. The 2 minus 3 would leave me at negative 1, negative 3, negative 5, and back to negative 3. I know I'm not going to be able to see this, so I'm going to try to grab it and bring it over here with me if I've got some room, so we can see what's really happening with our coordinates. Let's try to make it a little smaller too. And so at 0 we're at negative 3, pi over 2 we're at negative 1, pi we're at negative 3 again, 3 pi over 2 we're at negative 5, and at 2 pi we're at negative 3. Notice that our baseline is now down here at negative 3, and the baseline moved down vertically because we had the minus 3 up here. So our function was not only stretched vertically, it was also shifted vertically down by 2, and this is our new function. One of the ways I'm going to have you graph that is, or have you answer this question is, I'm going to ask you for the coordinates of some points, of 5 points. And so let's go ahead and try it. At 0 pi, we're at negative 3. At pi over 2, we are at negative 1. At pi, we're at negative 3. 3 pi over 2, negative 5. And then at 2 pi, negative 3. These are our 5 coordinates. We can do the same thing with cosine. Here's our basic cosine chart. Notice we have both an amplitude change and a vertical shift. The amplitude change comes first, so we're going to go ahead and triple all of our x coordinates. No, we wouldn't triple our x coordinates. With our amplitude, we're going to triple our y coordinates. And so we're left with 3, 0, negative 3, 0, and 3. Our x coordinates are staying the same. So we got that. Now let's go ahead and take care of the vertical shift. So again, a vertical shift won't affect our x coordinates, but now all of our y's that have already been amplitude by 3 will now move up by 1. And so we've got 4, 1, negative 2, 1, and 4. These are our 5 points for our graph. Let's bring it over here so we can see it. Maybe. Okay, and so we've got 0 is at 4, pi over 2, 1, pi negative 2, 3 pi over 2, 1, and 2 pi we're back to 4. Nice smooth curve here. Don't go off into space because you recognize it's going to come back down. The 5 points we want to have in our first cycle here are 0, and probably best to write 0 pi, 4, pi over 2, 1, pi negative 2, 3 pi over 2, 1, and 2 pi, 4. So that's how you graph a function that has both a vertical shift and a change in amplitude. Now try these examples on your own, and there's another video that will go along with them.